Hey, how's it going? This is Tech Ed Kirsch, and I'm bringing you a video talking about what is the optimal process in hardware design. Is there such a thing as an optimal process? Can you get first time right design? It is possible. I've seen it, and the people who I've trained have been able to achieve that as well. And it comes from handling hardware design and PCB design as a product based approach, a product design approach. So what I want to show you is the process that I use and that I've seen in industry as industry moves more toward this and is doing this already, which is maybe coin constraint driven design. But I like to coin it requirements driven design. Requirements driven design. These are the steps and the process you're going to need to use to make sure your design works right the first time or has a higher chance of working right the first time. And it's how it works in industry. It's how it works in product development. All right. I will quickly walk you through the key phases. In fact, I'll do a series explaining each of the tools you'll need, each of the processes, what are the expectations for doing a hardware design the right way. Okay. The iterative approach to PCB and hardware design, I feel like those days they're still going to be happening, but they need to be in a more controlled way. The iterative approach to find out more problems and what went wrong, those days are starting to come to an end. Those days are effectively over with our newer tools now. So I'm going to show you this process and how this works. So a lot of engineers, back in the day and even today, design some boards, hope it meets like their needs and whatnot, and I hope it's going to work. And then if it doesn't work, then they go back to the drawing board. This is a huge problem that I didn't know existed because this is not how we operate in the research lab. In the research lab, because I'm a university student, okay, a graduate student, and also a former adjunct professor, how we do it in the research lab is you get all of your variables, you get all your unknowns, your known unknowns, your unknown unknowns, and everything up front, and you use the scientific method and approach to get something done. This is how I approach power electronics and PCB design. Basically, if something goes wrong, it's because you left something out in the design process. A very popular guru in PCB hardware design is named Lee Ritchey. He released a book called Right the First Time by Lee Ritchey. When I encountered the iterative approach in hardware designs, doing like $50,000 board spins for a round of boards, and doing that like 2 or 3 times, half of a year, that's like 150K in 6 months, easy, right? Off of a few boards. And I'm like, this process doesn't make any sense. Eventually, I stumbled across this book, Right the First Time, a practical handbook on high-speed PCB and system design. This spoke to me. Why? Because he was the first one who I came across really calling out how iterations are usually the result of something that was left out, some simulation that was not done, that could have been done if you had the right tools, or if you employed the right process, or if you didn't skip certain things. All right. So this is the book that I strongly, highly recommend. That this confirmed my inner knowing from what I know from research and development, and how your equations your equation should solve out to where your PCB layout and your final product works just like your equations predicted. All right. If not, you left something out. So check out that book. Okay. Now here's the process. This is what I use at Hasofu and for people who I teach PCB and hardware design. And this is the PCB Design Mastery, the ultimate 10-step checklist for seamless PCB design. Now, I'm not saying that this is the only way to do hardware design or that this is the most robust process. I'm not saying that because there are other board design companies that take this like to the next level. I'm talking hundreds of pages or whatever. But I'm just sharing with you a process that I know works and the philosophy. You want to adopt this philosophy to make this work. Okay. So let's go here and let me show you. You have 10 design phases and 2 board bring up phases. Okay. You have initial planning and requirements. This is the most important phase. And it also happens to be number 1, right? But it is literally the most important phase possible. Everything in terms of the design, the library management, components, everything, it doesn't start at components. It doesn't start at design, schematic capture, any of that. It starts at meeting your requirements, and I'll show you why. The next phase is once you've come up with your initial plan and requirements, you need detailed requirements and specifications that meet your requirements. So let me give you an example of a requirement. A requirement would be, hey, I need something, a device that's going to fit in my hand, in my left palm or right palm most of the time, that I can talk on to talk to anybody in the world at any time. Okay, that's a requirement. I need a phone that can do that. What that does say, these are like the features and benefits. Requirements speak to the features and benefits you want in a product. Okay, and I just laid out the benefits. The requirements are that it needs to be able to connect to Wi-Fi. It needs to be able to let me tap it on the screen. I need to be able to, like, I don't know, put it in a thing and play hopscotch with it, whatever. It needs to be able to withstand a drop. These are more requirements, and the requirements are there to help you achieve some benefit as a customer. The benefit of being able to have conversations whenever you want to with your loved ones. The benefit of being able to make sure that you can carry your life in your hand, in the palm of your hand, and stay connected to your business, to whatever. Okay. Now, when we talk about detail requirements and initial design, we're talking about specifications, block diagrams, coming up with things that meet the requirement of connecting to Wi-Fi, right? And say, these are the features. These are the features that we need to include in this kind of device to make this give the customer, the user, the benefit. The benefit. Okay, so benefit requirements, and then we get down to detail requirements and specifications. The engineers would define a problem statement and the general requirements. There were mechanical requirements, what's required. And an enclosure, it needs to be a certain color, it needs to be metal brushed, it needs to be this, that, and the third. And then you have the electrical engineers who say, hey, we need some kind of processor to be able to do what you're talking about. We need an electric printed circuit board or PCBs. If you want to know PCB design, check out my course below on how to become an expert in PCB design in under a year, and really in 3.5 to 4 months. Okay, if you're serious about it. So click the link in the description below for that course. And then there's also, like, the electrical engineers will say you need terminal screws, you need something that can send signals out into whatever, into space and stuff like that. Okay, so those requirements are made up by the electrical and mechanical and all the other teams involved in this process. Once you have that in phase 1 and 2, phase 2 also includes detailed specifications to meet those requirements. So the mechanical engineer starts talking about what it needs to look like, the 3D modeling and all this. The electrical engineers start talking about what chips do we need, what kind of circuit topologies are needed to boost signal, things like that. All right. Also, protocols between chips. Chips communicate with each other through wires, and those wires communicate through signal timings that we call communication protocols. Okay. Understanding the protocols needed for your different chips, initial drawings of your system, definitely block diagrams. So where you write down the features and benefits in a block diagram of what needs to be delivered by the electrical design engineer and even mechanical. So they're working really closely together to meet the needs and requirements of the product from phase 1. Okay. The electrical engineer in phase 2 also, after drawing the block diagram, the functional block diagram and the system block diagram, shows like any differential pairs, single-ended nets, and starts really getting down into creating a design through drawings or through usually schematic capture tool like an ECAD tool like Altium. Speaking of Altium, thank you for sponsoring this video from this Altium designer. Okay. Altium is the industry leading company and software that produces this ECAD tool that allows electrical engineers to create schematic symbols, do printed circuit board design. So pretty much your computer motherboard, your circuitry inside of your car or your Tesla or whatever, it was likely done by an engineer using Altium and other ECAD tools. ECAD stands for electrical computer aided design, and this is what Altium looks like. Altium has like this strong ecosystem of online cloud solutions and also local solutions. Their biggest thing right now is called Altium Develop for solo designers. You can get access to Altium Develop by clicking the link in the description below. You'll get a free trial, and they have design phase where you do the actual design. Okay. The project, I'm talking to you right now about the project phase. This is in phase 1 and 2. And the requirements, that's phase 1. They have an online thing for setting requirements and putting it in your design. Supply chain for when you need to find components, manufacturing when you need to send the board out for manufacturing, and data to make sure you have the right design details. Okay. So if you are looking for an ECAD tool that is going to do you well and has a great, fantastic user experience, quite frankly, the best user experience, no joke. All right. It's smooth. It's like a software company took the user experience into consideration for once for electrical engineers. Because, you know, if you use electrical engineering software, as long as that thing works, the company's going to ship it. And good luck if you don't know how to use it. You just need to learn how to use it, right? But Altium is taking a different approach. They're kind of like an underdog. I really appreciate they take user feedback and actually make a software that you want to enjoy. You enjoy using. I love using the Altium software just as a tool. Okay, that's a long enough ad. It's not even an ad. Just try it out if you're really considering getting serious in electrical engineering design and PCB and hardware design. Okay. The electrical engineer would then do things like collect data sheets. Once they know the parts that they're going to use in general, okay, this is not a hard set in stone rule. But once they generally know what circuits they're going to do to meet the functional block diagram that they made based on the requirements in phase 1, then they can start selecting key parts. Like maybe you need an NVIDIA chip because you're making an AI board. Maybe you need a microprocessor from Texas Instruments or whatever. They start collecting that information, okay? Because these data sheets could disappear. Now I'm glossing over these things. If you want my in-depth process for each of these phases, then stay tuned. You may want to subscribe, and I'll highlight the in-depth steps for each steps of these process, each major step in this process. There's phase 3, which is library management. Once you have your design, your circuit design relatively locked in, loosely locked in, you start collecting part data sheets, part information. Then you start creating component libraries. You model them in your ECAD software or tool, right? So that's where Altium Designer comes in. I know it says Altium Develop, so this would include Altium Designer, right? And then the Designer tool is an ECAD software that models electronic products, right? This is kind of like Autodesk or AutoCAD but for electrical engineers. Just to draw a comparison. It has all the visuals, the circuit diagrams that you can make in Altium Designer, right? Altium Designer schematic. Let me show you. And this is what it looks like. See, you can draw your electronics diagram. And it also does wire harness too, cable and wire harness. Schematic. It is like the most popular ECAD software globally in terms of like ease of use and everything like that, and also for professional users. It has things like wire bonding. You can do HDI design, harness design, variant management, rigid flex, PCB, high-speed digital design, all of these. All right. Okay, this is where your engineer starts capturing those components, modeling them, putting them in, as little circuits and everything inside the Altium Designer software tool. We're talking about schematic symbols, 3D models, signal integrity analysis, component availability, finding components are available, supply chain, all of that is tracked in Altium. The requirements you would actually track inside, like in the requirements phase for the project. You would normally track that in, say, PowerPoint presentations or Jira tickets or whatever you use for managing your projects, right? Slack. But what Altium has done is they've created this thing called Altium Develop, right? Which is the cloud side of everything. When you take a tour of Altium Develop, like they say, they mention design. That's where Altium comes in, and that's all fine and good, right? But you have tasks in the cloud in Altium Develop. So this is the project. This is the bill of materials. So you know when your components are available for a design. And here's the requirements. You activate this workspace once you get the clicking the link in the trial below, or clicking the link in the description below to get the trial. You have access to your requirements. Now, what's so special about the requirements portal? It's not that different from using Jira, except it is specifically for electrical and electronics design engineering. Tolerances, voltages, impedances, and all that stuff. And then in addition, you can drop those requirements into the schematic into specific parts, specific areas, your schematic sheets. It's integrated. You don't get that anywhere else. I don't know anywhere else you get that. I mean, to be fair, there are other tools that do have that, but it's not as sleek as this. It's not as well executed, and this is just ahead of the curve. Back in 2019, when I was working as an electrical systems engineer, I didn't have a harness wiring tool or software tool that I could rely on that was smart, that had intelligence. We definitely didn't have requirements like this as a tool in any of the companies I worked at. It's relatively new, and the industry has been needing this for an extremely long time. Okay, that's where your requirements are done. Detailed specs and initial design also in the requirements portal. So there's that ecosystem for that. Hands down the best solution. Then we have library management, schematic capture done in the Altium Designer software. Then there's phase 4, schematic capture and analysis. Yes, to do that in Altium. There's a whole heap of stuff in here. This is just an overview video. I will cover each of these in detail in future videos. Then you have PCB requirements and stack up. This is handled on the PCB side in Altium and whatever ECAD software you're using. So PCB requirements stack up, you set up your PCB, your requirements. Make sure you get the PCB stack up from your manufacturer first. Don't just come up with anything. Use what the fabricator creates. Okay. And then this is where you do your board setup in phase 6 and floor planning, component placement, creating the board outline. Then you place your mounting holes. Then you define your part and routing restriction areas, adding documentation for your dimensions and all this stuff. Then you do your routing in your ECAD software tool. This is a whole heap of stuff. I have to cover it in a separate video. I'll have videos linked for each of these phases. Then phase 8 is your design rules check and post route verification. Again, still in your ECAD simulation, your ECAD software. And you may employ other external software tools for signal integrity analysis, EMI, okay, and other PCB simulations. Finally, once you verify that everything works, you check for designing for manufacturing, more simulation as needed, final signal verification, power distribution network simulation, and then you have phase 10, packaging and ordering the design. At this phase, you know everything works within reason, and then you start generating these files called Gerbers. Gerber is the most popular. ODB++ is becoming much more popular now. IPC 2581, that's another output format for fabricators to fabricate your printed circuit board and for assembly houses to assemble your printed circuit board. There's two separate things. Sometimes companies can do both. All right. Then phase 11, once your fabricator and assembly house have created your PCB for fabrication and assembled the components on the PCB for assembly, creating a PCBA, a PCB assembly, then they send it back to you, and then you're ready for testing and release. They also do some testing as well, or if you want to pay for more in-depth testing, you can pay them. Then it comes back to you. You then do your own in-house testing, right? To make sure it works as intended, and then you take it into production. Now, here's the thing. The testing usually finds the problems and the issues. The ideal process is right in phase 8 and phase 9, where you do simulation of the printed circuit board. It is an entirely different domain, the mechanical, electromagnetic domain, thermal, all that stuff. Entirely different domain than just verifying that the circuit works and conceptually. It's not enough. It's not enough. You need to have your signal integrity AMI tools to do your simulations to make sure your board is going to perform the way you need it to perform based on your what? Your requirements from phase 1 and your specifications from phase 2 to meet the requirements. Okay. Well, I think we've covered everything. Phase 12. Once you know your board works and you're testing and release, you may need to change some things after phase 11 or during, and then do an iteration to update the board because, the real world and the simulation are always slightly different. Okay. Once you've done that, you may go through an iteration, change things in the design. Some things may not work. Some things may not work as well as you want them to, even though they do work. And then you go through that whole process again, changing little things. Once you get through testing again through another version of the board, and that's good, you're ready to scale and go to production. Optimization for pricing, for PCB layout, all this good stuff. When you're at the production level and phase, this is when you start increasing your profit margins and whatnot for your products, okay? And every little decision counts. If you lose 1% of your producibility, you could lose tens to hundreds of millions of dollars if you're a company as big as, say, like Apple. All right, so that's just a general overview of the hardware design process for anybody who's confused about what the process should look like. The key things being the requirements phase and then the simulation phase, verification phase, and phases 1, 8, and 9 respectively. Those are what really get the modern hardware design process, but why I call it the modern hardware design process. Without those things, the simulation, verification, and having something to track you meeting your requirements well and consistently, then you're doing iterative design. All right, you're doing mostly a lot of iterative design and best practice, hope for the best design. We can't afford to do that anymore. That's why we have these tools. If you're wondering, well, how do I get access to these kinds of software tools and whatnot, particularly Altium Develop, which does follow and enable the full implementation of the modern hardware design process, click the link in the description below. Let me know if you have any questions. Now, there are third-party software you need to use to verify certain things like power distribution analysis, but you can add them on as plugins to the Altium Designer software. In any case, I'll come back to this and expand on each of these topics within the process in future videos. If this has been helpful, share this video, like, subscribe, comment below, tell me what I missed. There's a whole lot of stuff to cover in here. All right, I'll see you in the next video. Peace.